Welcome to AminAcademy.com in electrical engineering regarding Coulomb's law. Let us do some solving problem. Look at this. Consider 2 point charges Q1 and Q2 at rest as shown in figure. That is, in x-axis, they kept Q1 charge and Q2 charge with 1 meter apart. They are separated by a distance 1 meter. Calculate the force experienced by the two charges for the following cases. Case 1, look at here. Q1 is 2 microcoulomb, Q2 is 3 microcoulomb. Both are positive, so it's repulsed each other. Then second one, case B, Q1 is 2 microcoulomb, Q2 is minus 3 microcoulomb, so it attract each other. And third one, Q1 is 2 microcoulomb, Q2 is 3 microcoulomb, kept in water some other permeable in water, that is epsilon r is 80. Now we'll do the solutions. First, look at here. This in case 1, F12 force from 1 on 2, and at Q2 force F2 on 1. Both are repulsive each other because both are positive. Then case B, both are attractive because F12 and F21 in opposite directions, so it is attract each other. And this one, this also attract each other, but with some other permeable space. Now answers 1, Q1 is 2 microcoulomb, Q2 is 3 microcoulomb, both are positive, R is 1 meter, both are positive charges, so the force will be repulsive. The force F21, that is force of 2 on 1 is 1 by 4 pi epsilon 0 Q1 and Q2 over R square K vector 1 2. Now here K vector 1 2 is the unit vector from Q1 and Q2. Since Q2 is located on the right side of the Q1, we have now therefore, here R cap 1 2 is the unit vector from Q1 and Q2. Since Q2 is located on the right side of Q1, we have K vector R12 equal to I vector because in horizontal direction, so that force vector F21 is 9 into 10 power 9, that is 1 by 4 pi epsilon 0 value, and 2, that is 2 microcoulomb and 3 microcoulomb into 1 meter square. So this we have 54 into 10 power minus 3 Newton in I direction, that is horizontal direction. According to Newton's third law, the force experienced by the charge Q1 due to Q2 is F12 is opposite reaction, that is minus F21. So that F12 is minus 54 into 10 power minus 3 Newton in I vector. Here this is a positive, this is negative. The directions of F21 and F12 are shown in this above figure. Here. Next, case B is here Q1 is 2 microcoulomb and Q2 is minus 3 microcoulomb. The same procedure. Look at here, F21 is 9 into 10 power minus 9, that is 2 into 10 power minus 6 minus 3 into, so it gives minus 54 10 power minus 3 10 power minus 3 Newton I direction. Here the same cases, F12 is positive 54 10 power minus 3 Newton I vector, F21 is negative, F12 is positive, and vice versa also I can take it. Now third case, this vector 21, that is F vector 21 is 1 by 4 pi epsilon Q1 and Q2 R square. Here the value epsilon is 80. So we are keeping this permeable for water, this here 54, previous result 54, but 80 because it's a permeable 80. So which gives minus 0.675 into 10 raised to minus 3 Newton in I direction. So we calculated all the things on looking this problem already solved. Next question. Consider 4 equal charges Q1, Q2, Q3 and Q4 which is equal to Q of positive 1 microcoulomb located in circle. The total force acting on the Q1 due to all other forces. That means we have to calculate force on Q1 regarding Q2, Q3 and Q4. That is displaced like here Q1, Q2, Q3, Q4 are at each 90 degrees they are keeping from the origin. Then according to the superposition principle, the total electrostatic force on charge Q1 is the vector sum of the forces due to the other charge. Here you have to find by using superposition force on Q1 because of Q2, Q3, Q4 is the vector sum of this from Q1 to Q2, from Q1 to Q3, from Q1 to Q4. That is F1 total is F12, F1 total is F12, F13, F14. These are vector sums. The following diagram shows, look at here. Now we are drawing a line through Q1 to Q2, Q1 to Q3, Q1 to Q4. That is distance between them is R21. This distance is R31. This distance is R41. Here joining the line Q1 and Q2 and extend this way and joining Q1 and Q4 and extend this way. This is now two resultant vectors are here F14 and F12 with direction x-axis to the 45 degrees because it's joining them is a square, then this degree is 45 degrees. Now components of vectors of along y direction is F14 sin theta, here F14 cos theta, and this direction F12 sin theta, and this is F12 vectors. So we have to solve this. The charges Q2 and Q4 are equidistances. Q2 and Q4 equal distances because it's each 45 degrees separated, and as a result of strength magnitude of the forces F12 and F14 are the same even their direction are different. Therefore the vectors representing these two forces are drawn with equal lengths, but the charges Q3 is located far away. Q3 is located far away than Q2 and Q3, Q2 and Q4. That is, this Q1 to Q3 is more distance than from 2 and 4. Therefore, look at this one distance. This is unit vector, that is radius is 1 meter. Then you can say this diagonal is √2. Diagonal is √2 meter. Therefore, look at here, from the figure R21 is √2 meter, that is R41. R31 is 2 meter. R3. Therefore, F13 is K into Q square over distance R31 square, that is R31 is 2 meter, that is it's become 4 square, 2 square is 4. Therefore, F13 is 2.25 because by calculation this one 2.25, that is 9 by 4 is 2.25 into 10 raised to minus 3 Newton. Then F12 is KQ square over R21 square, where here the distance between them R21 is √2 that root 2 squared is 2, therefore it is 4.5 into 10 raised to minus 3. From the figure, angle theta 45 degree, we know that. In terms of components we have, therefore F21 is F12 cos theta I minus F12 sin theta j. So adding them, vector sum is 4.5 into 10 raised to minus 3 into cos 45 is 1 by root 2 I vector, then minus 4.5 into 10 raised to minus 3 into cos 1 by root 2 j. Therefore, the vector sum is F1. Therefore, this is the F12. That F13 is F13I, that is 2.25 into 10 raised to minus 3 Newton in I vector. F14 is component, that is F14 cos theta I plus F14 sin theta I. This. So here, this 4.5 into 10 raised to, that is F14 into cos theta, cos 45 is 1 by root 2I, like here it's also positive. So these are the components. Now we are adding, then the total force on Q1 is F1 is equal to F2, this first things added and the second things added here. First F12 cos theta I minus F12 sin theta j plus F1 3I plus F14 cos theta all added together, which gives this I is common and j is common here. Since F12 and F14 jth component is 0, here practically no components, because therefore F total equal to F12 cos theta, F13 plus F14 cos theta. Therefore, we are using the values of those values before you got it, that is 4.5 over root 2 plus 2.25, 4.5 over root 2 I. Simplification, we get 4.5 root 2 plus 2.25 I vector. Totally, we are adding this, we have in decimal, F1 total is 8.61 into 10 raised to minus 3 Newton in I direction. Here, this looks a little complication, but by using this diagram, we can get it the values. That means force on Q1 due to Q2, Q3, Q4 together is vector sum, and we got the values here. That is F1 total is 8.61 into 10 raised to minus 3 Newton in I direction. We have done. Please subscribe our YouTube channel.